cubed plus m squared minus n cubed minus n squared, like that. Any ideas, kids? Any ideas of what you can do? What do you see in there? Can someone tell me what you see? Tell me one specific thing you see, Alex. What do you see? I see two variables. What else do you see, Hannah? I see differences cubes and I see differences squares. So I see m cubed minus n cubed, and then I also see plus m squared minus n squared. What is m squared minus? This is called what? What is that called? Difference of squares. Exactly. So what does that factor into? M plus n times m minus n. Okay, so we factored that, but now we need to factor the difference of what? Difference of cubes. And do you remember what the difference of cubes was? The formula? It was x cubed minus y cubed is equal to what? Anybody remember? You have to memorize this. What is it, Alex?
X minus y
times. You gotta get, kids. I told you last week you have to memorize this. It will become a like enter this class or not kind of question if you don't memorize these things after a week. Okay? It is not acceptable that if you are asked to memorize a basic sentence in history or English, you would do it instantly, but not in math. You must memorize this. I can't be clearer. Can anybody finish this for me? Nikki.
x squared.
Yep. Yep.
Minus x.
Nope.
Minus y.
What is it? Can someone tell me what this is going to factor into then, right there? What's it going to factor into? Nope. No. Kids, you're applying this. You're applying that to that situation. Thank you. So you're using this formula now, okay? It's going to be m minus what? Times what? M squared, yep. Mn plus n squared. Exactly. And they're not being multiplied together, are they? It's added right there. Like, these are being added, correct? Let me get these out of here. The blue is right there. So they're being added together. Nice. Now, are you done? Are you done? No, you are not. Well, first of all, let's just label this. What was that called again? Difference of cubes. Now, you have two things here. You have these two things right here. What is in both of them? M minus n is in both of them. M minus n is in both of them. There's m minus n here, and there's m minus n right here. So what can you do with that? Factor both of these out. So what do you end up with? M minus n times m squared plus mn plus n squared, right? Plus what?
M squared.
Nope. M plus n. So where did these things come from? This thing went right there. This thing went right there. And both the m minus n, where did that go? Went right here. Now, is there anything else you really can do to this? What do you think?
No.
Doesn't really look like it, does it? I mean, the thing is, are there any terms in here that you can combine? Are there any like terms in this thing? There's an m squared, there's an n squared, there's an mn, there's an mn. There are no like terms. So at this point, you would stop. This right here would be a great final answer right here. You could, if you wanted to, you could write it as m minus n, and then you could write m squared plus n squared plus m n plus m plus n. I just got rid of all the redundant parentheses. You would leave it like that. That would be a fully factored form. Totally fine. And difference of cubes, and then just do them separately, and then they pull together a little bit. What's the first thing what's the first thing that pops out at you as why is this a little different than something we might have not done before? There's 3 variables in this. Do you notice how there's 3 variables? So here's what we're going to do. We are going to just look at this part right here first. Let's just look at that part first. How many variables are in that red box? So let's just park this 4r squared over to the side, subtracting, and let's factor out I like to factor out a negative, right? You know, if I factor out a -1, what am I left with? S squared plus 2st plus what? So the idea here is we're going to try to factor this. We're going to try to factor that and see if that's helpful. Everything else is along for the ride. We're just trying to factor that. Anybody know what that factors into? Anybody know? What do the first 2 terms multiply together to get? S squared. What do the last 2 terms multiply together to get? T squared. So theoretically, you could have, what could it break down to, do you think? S plus t times So we're not sure if that's correct. What do we have to do? Test it. So that's going to be s squared plus st plus ts plus t squared. What does that simplify to? Is that what we want it to be?
Yeah.
So what do we now have? We have 4r squared minus what? S plus squared. Oh, look, what do you see? What do you see right there, kids? Difference of squares. So what's another way to write 4? 4 is what squared? So this is just 2r squared minus s plus t squared. So what does that factor into? 2r what? Minus s plus t times what? 2r plus s plus t. Can you go any further than this? No, this would be totally done. This would be pretty. This is about as hard as it would get with regards to the kind of factored questions I would ask you as part of the test. This is about as hard as it gets. I mean, look at what you have to do here. You look at it and you first notice, hey, there's 3 variables. Well, you haven't studied really anything with 3 variables, so just do 2 at a time. See what happens. The other thing that should strike you immediately, when you look at all the numbers involved here, what number jumps out at you? What number do you think jumped out at me? The 4. The 4. The number 4 jumped out at me, and I think, oh, 4 is a square. Do you have 100 different ways to factor? No, you have like 3 or 4, right? One of them has to do with squares, and there's some minuses in there, so maybe you have an intuition that there's going to be difference of squares here. Is there going to be difference of cubes? No, there's no cubes in there, right? So you think, oh, squares, oh, let's see what happens. Oh, look, it worked pretty nicely. Yes, Nick. Squares, there was a really cool thing written on the board. I don't remember what he said exactly. What was his character? It was like, something like that, dot squared minus like, does it matter what those things are? No, that's the difference of what? Square. So it's the first thing plus the second thing times the first thing minus the second thing. Exactly. Anyway, any last questions? Yeah. Someone say catastrophic? Yeah, it becomes prime, right? Like all of a sudden it goes from doable to not. What's the challenging thing about number 58? What was the challenging thing about 58? What's the first challenging thing about 58? The coefficient is 18. That's the primary thing that kind of gets messy, right? So it means that there's a bunch of things to test because 18 could be 9 and 2 or 6 and 3. And then what about the other one? 35? Oh, man. But if you test it, eventually do you find something that works? Yeah, what did you find that works? 9p minus 5r, right? And then what do you multiply by? Can someone erase that while I'm doing this? Times what? 2p plus what? 7r, yeah. So how do you, there you go. How do you test to see if that's correct? There's an eraser right by your hand. Please don't use your hand. It makes the board a lot worse. There you go. What was the challenge about the second one, 60? What did you have to see? When you looked at 60, what's the first thing you saw? Squares. You see squares. You see squares. So you should think to yourself, difference of squares. This is almost identical to the one we just did. You look at it's even grouped nicely.
You put that together.
Yes. What does that mean? That is.
You could say x squared plus y squared. You know?
No, you can't. You don't have sum of squares. You have difference of squares. Okay. This right here, you're going to eventually recognize that can be turned into what? X minus y times. Yeah. And this just gets dropped down, minus 4.
Oh.
It is x minus y times. Oh, what is, when you multiply something by itself, it is what? Squared. It is squared. So you have x minus y squared minus 4. What do you see right there? That is the difference of squared. That is x minus y squared minus what squared? 2 squared. The formula you have is q squared minus r squared is equal to q plus r times q minus r. This is exactly what we just did. So in this case, what does q equal in this case? Q is x minus y. And what's r? 2. So we use that formula and we end up with q, which is x minus y plus r times x minus y minus r. And you're done. There it is. You're done. That one's a little bit more complicated because you do end up with 3 terms times 3 terms. If you wanted to check this one, how would you check this one? What would you have to do to this? You have to multiply. Now, how many different multiplications do you have to do? Everything in the first times everything in the second. How many things in the first are there? So each thing in the first has to be multiplied 3 times. So there's 9 of them. Let's see if it works. What's the first thing we multiply? X times everything, right? What do you end up with? X squared minus xy minus 2x, right? So let's do the next one. What do we end up with? Minus xy plus what? Y squared plus 2y. And then we have another one here. We have this one right here, right? What do you end up with? 2x minus 2y, right? Minus what? Is it minus 4? Because it's a plus 2 and a minus 2, right? So does something cancel out here? I think this cancels, right? Anything else cancel out? Oh, this cancels right there. So what are you left with? X squared minus 2xy plus y squared minus, is that what you want it to be? Yeah, absolutely. So here the key was recognizing this pattern right here. There are some patterns you have to recognize. Okay, so let's pause for 1 second. Hannah, can you go up and erase all the boards with an eraser, please?